All right, we're back. Okay, we're going to start today off with a little review. All right, remember to follow along carefully and write this stuff down. Here we go. Starting off with chapter 7. How many diagonals can be drawn in a 16 gon? Well, first of all, if you remember, we have this formula D equals N times N minus 3 over 2, where N equals a number of sides. So since it's a 16 gon, all you do, plug in 16. 16 times 16 minus 3 over, not over, let's say over 2. It should be over 2. My fault. Over 2. Over 2. Which ends up being 104. Remember, take care of the subtraction first here. All right, so that's 13 times 16 over 2, or you could do 16 divided by 2, which is 8, and 8 times 13 gives you 104 diagonals. Boom. Easy peasy, lemon squeezy. Remember, if you have any questions, write them down, or you can come ask me in class right now. All right, here we go. How many sides does a regular polygon have if the measure of each exterior angle is 4 degrees? All right, remember, all angles, all exterior angles, their sum is always going to be 360. All right, so if you want to find the measure of an exterior angle, that's what ME means, the measure of, wow, exterior angle. You just do 360 because that's the sum for any regular polygon. The sum of the exterior angles for any number of polygons, all right, is 360. So you do 360 divided by the number of sides. So in this problem, we're wondering how many sides the actual polygon has if each exterior angle is 4 degrees. That means 4 equals 360 over n. Holy cow, I'll put it over 1. Crisscross applesauce, 4n equals 360. So n equals 90 sides. Trying to use a stylus, it's not working out too well, people. Ninety sides. There you go. If you have any questions, let me know. All right. In chapter 8, we talked about similar triangles. Okay, similar triangles. There were 3 ways that we used to prove triangles similar. There was angle squiggly, which means angle similarity. All right, side angle side squiggly or similarity, and S squiggly. Before you ask, no, there's not a proof on the final, but you will have to decipher if a certain numbers of triangles are similar or not. Okay, so if we want to find if these are similar, well, remember all 3 of these angles have to add up to 180 degrees. So if I add 28 plus 140 and subtract it from 180, I get 12 degrees. What? 12 degrees? That doesn't seem right. No, it's not. If I add 140 up here plus 14, I get, and subtract it from 180, I get 26 degrees. So are these 2 triangles here similar? No, they are not, because they only have 1 congruent angle, not 2 pairs. They need at least 2 pairs of congruent angles. So these are not similar. All right, let's look at these 2 triangles. I'm looking at is A, B, E, triangle ABE similar to triangle, excuse me, ACD. That's the question we're asking. Is ABE similar to ACD? Well, if you look here, you got 26, 56. If you subtract from 180, this is going to be 98 degrees. Uh-oh. So I have 1 congruent angle here and 1 congruent angle here. I bet if I do 26, I'm looking at the huge triangle now. Remember, there's those 2 triangles. The big one, which is ACD, and the smaller one. Sorry, I had a little someone knocking on my door. All right, so the big triangle is ACD, then the smaller triangle is ABE right here. Okay, so Are these two similar? Well, I guarantee you, if I look at this yellow triangle, if I do 26 plus 98, I bet you this is going to be 56. So are these two triangles similar? Yes, they are by angle similarity. Boom, boom, pow. 3, 2, here we go. Well, excuse me. All right, let's just find y. I'm only concerned about finding y because this is the one type you'll see on your review packet and type you see on your final. Remember, this is one of those Starbucks problems where this is 90 degrees and this is 90 degrees. Starbucks meaning the small, medium, and large triangles, okay? If I'm solving for y, which two triangles do I take out? Well, I want at least two sides. I have one here, and I have one here. Starbucks, remember, small, medium, large. So if I take out the green triangle, I have 5 and y. If I take out the medium triangle, I have y and 8. Well, what do I see twice? I see y in this triangle and y in that triangle. That means y is the geometric mean between 5 and 8, which is 5 over y equals y over 8. Like that. Then you cross multiply and solve. Right, you don't have to simplify that radical, but I'm not going to do it. The most important part is the setup. You should get y squared equals 40, and then take the square root of both sides. Here we go. All right, a telephone pole casts a 36-foot shadow. Standing next to the pole, a man casts a 6-foot man casts an 8-foot shadow. Well, okay, you ready? Here's my telephone pole. All right, I cast a 36-foot shadow. Here's my guy. Give him some hair, some weird hair. That's different. He's smiling. Well, he's 6 feet tall, and he casts an 8-foot shadow. So this goes back to our similar triangles again. All right, similar triangles is from chapter 9. I want to find how tall the telephone pole is. So there's my telephone pole. So hey, now I'll just set up the ratio. X over 36 equals 6 over 8. Okay. You could have also done x over 6 if you went left to right, big to small. You have to go big to small again. And then crisscross applesauce. I'll do it over here. 8x equals, what is it, 216? So x is 27 feet. Bam. Again, if you have any questions, let me know. All right, the key to these problems is drawing two triangles. All right, drawing two triangles. 2. All right. This is one of those trig problems, okay? Or it can be a trig problem if you want it to be. So I have this house. Let's see. Let's put a house in here. Little box top. Draw the house. Wow. There's my house. Isn't that beautiful? That's me. There's my chimney. There's some guy. Hey, for sure. What's going on? Those are his fingers. Yeah, for sure. All right, so it says there's a ladder leading up. Here's the ground, right? There's a ladder leading up against the house right here. All right. It says it makes a 60-degree angle with the ground. Holy bucket, 60 degrees. Okay. The ladder touches the ground 7 feet from the base of the house. From the base of the house. So that means this is 7 feet right there. Okay. What does it say? How long is the ladder? So our x is here. Now there's two ways we can do this problem. You can assume this is 90 degrees. All right. So if this is 60, this is 90. Then this is 30. So we have a 30, 60, 90 triangle. All right. Remember, in your general case, across from 30 is your x. All right, so that means x is 7. Across from 90 is 2 times x. So that means this has to be 14 feet. the heat. There you go. Bam. Now you could have used trig, but we're going to use trig in the next problem to solve a problem like these, or like this. All right, so this is just a 3069 triangle. The key is just to draw a picture. All right, what is trig? What is trig? Do you guys remember? Hopefully, you should remember this. So, SOHCAHTOA. All right, SOHCAHTOA. Where the S is sine, C is cosine, T is tangent. All right, this is from 9.9 to 9.10, I believe. Had a big packet that we used over 3 days, all right, for this unit. Okay, so the key to trig, first of all, if we wanted to find what h is, you just do the Pythagorean theorem. Okay, you have two sides of your right triangle, you want to solve for the third, you do the Pythagorean theorem. All right, but now I want to solve for g, a missing angle, right? This is my reference angle. Okay, so from G, this side is across from G, so that makes it the opposite. Here's my 90-degree angle, so this has to be the hypotenuse. And this is our leftover side, so I'll call that my adjacent. So in this problem, I'm looking to solve for G, right? But I have O and A. So of the three that use tangent is the one that uses both O and A, so that tells us we need to use the tangent function. All right, remember you always take the trig of your reference angle. So tangent of G equals O over A, or 9 over 5. You remember how to find an angle. To find an angle using trig, you have to use the inverse operation. So G is equal to tan inverse of 9 over 5. Remember, that is, you do that by pressing second tangent on your calculator. All right, the inverse function calculates angles. All right, remember your mode must be in degrees and not in radians. So you get G is 60.95 degrees. All right, 3, 2, 1. Now this is another 30, 60, 90 triangle. We're expert at 30, 60, 90s. Just a heads up, this has to be 60, right? Holy buckets. This has to be 60. And across from 60, remember, is x radical 3. So you set x radical 3 equal to 12 and solve. Remember, you got to divide by radical 3. Divide by radical 3. Uh-oh. Oh, boy. Oh, come on. By George. Okay, so I have x equals, these cancel, 12 over radical 3. Then we are such experts at this, times radical 3. So x is 12 root 3 over 3. Some of us are able to do this in part in our head. So x ends up being 4 root 3. Okay, if x is 4 root 3, then that's what d is. D is 4 root 3, and this is 2x, so that's 2 times 4 root 3, which is 8 root 3. All right, that is review day 1 for you. Okay, if you have any questions, write them down. Come ask me. All right, or ask me tomorrow if you chose to do this for homework. Okay, that is it. Goodbye.